Right, so hello and welcome to the second day of the conference. I hope you enjoyed the drinks yesterday, yes? All right, so are you ready for a revelation? You will get hacked. Maybe not this year, but your time will come, don't worry. Or worry, I don't know which one you prefer. You see, the concept of bulletproof security is a myth. It's a cat and mouse game. Every time you come up with a new defense, the hackers are going to come up with a counterattack. So they're constantly getting ahead of you and you have to keep up. And eventually they will get ahead of you and you won't be able to react in time. And you will get hacked and your data will get leaked. And it happens to the best of us. It happened to Dropbox, leaked 78 million user accounts. Adobe, 152 million accounts. LinkedIn, more recently, leaked 164 million accounts. And Yahoo originally announced about 500 million accounts, but apparently there were multiple breaches over several years, and they leaked over 1 billion user accounts. So it happens to the best of us. People with a lot of money for security, they still got their data stolen. But this talk is not about how to prevent the data breaches. It's about how to prepare for them when they eventually happen. Steps you can take now so that when it does happen, you're in a much better situation. My name is Filina. I'm a project rescue expert. I develop, I train, I speak at conferences. I have a company and I organize 2 conferences, so this one in Montreal and another one in Vancouver. So that's me, shameless plug. Ways that you can get breached. Of course, hackers, SQL injections, and other ways that they can hack you. All sorts of clever hacking techniques. But it's not just hackers. So when you harden your security, when you harden your application, you think in terms of malicious attackers from the outside of the organization. But you also can have employees who are dishonest. Maybe they need some money for this month. Maybe they have a gambling debt. Who knows? They can walk away with credit card numbers from your company. So if you're storing them in a way that's accessible and you implicitly trust everyone on the inside, you can end up in a bad situation. And it's not just that, you can also hire consultants. And let me tell you a story of $5 consultants. What is that? All right. So the story goes, and this is a true story, but I will not name names. It's the story of an enthusiastic entrepreneur. And he created a startup in financial tech. And one day, he had a bug in his system on his production server. So he went on this website where you can hire anyone to do anything for $5. In retrospect, that might have been a bad decision, especially for somebody working in financial tech and giving financial advice. The ROI on that is dubious. So he hired a guy from a country that I will not name, and he gave him root access to his production server. I don't really need to tell you the rest of the story, right? You already know all the things that come out of it. Right, so things like that happen, and maybe you're not that entrepreneur, maybe you will not hire somebody for $5, maybe you will hire someone for $100,000, but this is still a possibility. Another story that happened to me personally was I was helping a client, and a previous consultant decided to go into the server and cause trouble. So he just went in, he had access, he had one of the authorized keys there, and he started messing around. First thing he did is he pulled the plug on my own connection, banned my IP address, which is a static IP, which means that I cannot get in. But then I went and used my cell phone to get a different IP address through the cell phone, logged into SSH, put all the security measures in place, and then pulled the plug on him to make sure that he doesn't go away with any of the private user data. So things like that happen pretty often, more often than we would like to admit. So it's important to make sure that, for example, you don't use server passwords. I'm going to touch on security a bit. For example, you should instead use authorized SSH keys. So there's this file called authorized keys that you should use instead of just giving somebody a password. Because if you give everyone a password and you need to not let one person in tomorrow, you cannot do that because now you have to change the password, you have to update it with everyone else, tell them, okay, here's the new password. Instead, you can just delete the SSH key of the person that you no longer want to get in. So what is sensitive data anyway? There's all sorts of sensitive data. There's passwords, credit cards, social security numbers. You have current location of a person. So for example, when the person turns on the GPS, you can track them, except if they want to broadcast. Obviously, people can always broadcast their sensitive information. If they check in on Foursquare or SwarmApp, you will be able to see their location. That is their choice. They can broadcast sensitive information. They can give out their mother's maiden name online. Yeah, they can broadcast all of that. They can receive a new credit card by mail, take a picture, hey, look at my new credit card, and post it on Twitter. That is their choice. That is not your responsibility. But you should still store all your data in a secure manner, or sometimes maybe not store it at all. IP addresses also, in most countries, are considered private information, so you shouldn't transmit it to someone else without prior permission from the user. So pretty much any data that you gather about your users is sensitive. And we'll focus on just the first two today, the passwords and credit cards. How do you get ready for a breach? Well, there are three main aspects. You should store less sensitive data. The less you store, once data gets leaked, well, there's less data in that leak, obviously. But of course, you cannot just turn off all your computers and put them in a closet and not get them on the internet. You still have to store stuff in order to be able to operate. So whatever you do store, make sure that when it gets stolen, it is useless, so that attackers cannot immediately consume that data. So things like credit card numbers or passwords, their passwords will be hashed or something like that. So they cannot use it right away. And also, the third thing is you have to implement post-breach procedures. Now, post-breach procedures is something that you have now that you can you can have a written procedure of how to do things, but you can also implement things now so that when something does happen, you can react in seconds instead of weeks. Because once you have a breach, everybody will be on high alert. You're going to have so many things to do that you will not be able to get to certain tasks until maybe weeks later. So you have to implement certain things now, and I will show you some examples. So storing less sensitive data. In some places, it is completely illegal to store credit card information. And even when it is legal, you have to have PCI compliance. So you probably shouldn't, because if you are not PCI compliant, what happens is that you will be fined anywhere between $5,000 and $100,000 per month. And you get fined by either MasterCard or Visa, anyone you have a contract with. And even if your contract is not directly with the credit cards, you have a contract with the payment gateway, and they have a contract with those companies. And that payment gateway, they're going to get fined by the credit card, and it will just pass this on to you. So you have to be very careful. Basically, I recommend against storing credit card information. But yeah, right, you need it for recurring billing, right? That is the number one reason I get when I tell people not to store credit cards. That is the first objection. But the thing is, do you actually need the credit card number, or does the payment gateway need the credit card number? That's the difference. Like, what are you going to do with a plain text credit card number? There's absolutely no reason for you to have it. If you want to display something on a receipt, you only need the partial, maybe the last 4 digits. Same when you interact with your customers, they call, they said, well, which card did you charge it on? Oh, the last 4 digits are these. So you don't, as the company, you probably don't need it unless you're in the business of processing payments yourself. But if somebody does it on your behalf, they need the plain text credit card number, not you. And they have all the compliance, they have security that goes with that, they have insurances also, so you don't have to worry about that. And this is why what you should do is use something, a vault. So all serious payment processing gateways, they have a vault. And the vault is somewhere where you store the credit card data. So it stores it for you, and so you don't have to worry about the security of your stuff. So here's how it works. Here's how vaults work. You, the company, gather credit card information from your clients, and you don't store it anywhere. Directly, you send it to the payment gateway, to the vault. So you don't touch it for too long. Basically, just collect it and forward it. You forward it there. It sends it to the payment gateway's vault, stored securely, and it returns a token for you. And then you can take that token and you can store it in your database. You can take the token, it can also send you back a partial that you can store, but not the entire thing, like no CVV, no expiry date, no full number. It just sends you a token, which is like an identifier with which you can then go and say, this is what I want to charge this client. So when you are ready to process the payment, all you need is the amount in the token. You don't have access to the plain text credit card anymore, not at any point in your life. And the token allows you to process the charge. That is the only thing it's good for, because they have the actual number. So you send them the identifier, charge on this credit card that I gave you previously. And if you attempt to extract the credit card information, all it will give back to you is a partial that looks like this. And you can still put it on receipts. You can still communicate with the client about that. But not even a developer with full access to your database can get anything out of it. So if there's a data breach, there's nothing usable in it, right? There's like just 4 digits, so back to square one. But there's one thing to be aware when you implement vaults, and this is sessions. Don't store the raw data in sessions, because where are your sessions stored? Either on a file, in a database, so on disk, in RAM, but it is still accessible by someone, right? So if you store it there during, let's say, a multi-step checkout process, it is still accessible there, even if for a short period of time, and somebody can monitor that and leach those credit card numbers from it. So what you should do is, once the user submits credit card information to you, you send it directly to the vault, get the token and the partial, and then store that in the session. And that means that if the user goes through multi-steps and then goes back one step where they enter the credit card number, they will only see this. They will only see the partial, and they can edit it. They will never see the plain text. They have no need for it, right? You are secure. Basically, in terms of implementation efforts, this is all nice, but you wonder, how long is it taking to implement the vault? Well, I implemented an e-commerce solution once, and it took me about 5 hours total to do the vault part. And that means reading the documentation of the payment gateway regarding that, implementing everything, testing, deploying. So basically, you have no excuse not to implement that. It's just a 5-hour effort for one developer. So when you do go home tonight or after the conference, I would suggest that you implement the vault if you don't already have that. If you're storing any credit card information, do that. Mention me and I'll retweet you to spread the good word. That's a deal, right? Okay. So my Twitter is @Filina. So there are other places where you can inadvertently store credit card information, and that is in comments. So when the users complete the transaction, they might have a field where they can add special instructions, and they might put something like, please charge half of the transaction on this credit card, expiry date CVV, and the other half on this credit card, expiry date CVV. And they just put it there. It's like when you put a trash can in a recycling bin, and people still put pizza slices in the recycling bin. Like, you cannot really control what people do. You can only provide instructions. Also, it's something that your admins can do. Well, I mean, as in people who manage the customer accounts, it is something that they could do, put things in notes. Oh, the customer called me and they said to change their credit card to this. So those credit card numbers can find their way into places where you didn't expect them to be. And that's why I would recommend that what you do is detect those patterns of credit card numbers and other sensitive information and just strip it out. Worst case, you just put some stars, and the person who manages the account will have to call back the customer to get that information, to get that into the vault properly. So don't let that lying around, because if it's in comments, it's in plain text, then when the data gets leaked, they will not even have that encrypted. The attackers will have it in plain text. So just be mindful of that fact. Now, the next thing we're going to talk about are passwords. Obviously, passwords, you're not going to store them in plain text. I hope you don't. But also, don't just store a hash. So hashes were the thing a few years ago, MD5, SHA-1, but that's not working anymore because there's a thing called rainbow tables. And what's a rainbow table? It's basically you create a bunch of permutations, string permutations of possible passwords, starting with the most common passwords. You have dictionaries of common passwords. like admin, password, 12345, things like that. Jesus is actually a very common password. It's not a joke. I think it's like number 3 or something. So yeah, they're going to go through those permutations, and they will pre-calculate those hashes. So they'll have in one column the plain text, and in the other column the MD5, SHA-1, and other possibilities. And these are already pre-calculated. You can probably download them. So you don't even need the processing power to do that. But then there's another thing. So basically, yeah, when they steal when they steal the passwords, they can just look them up, and they will be able to guess which password is the right one. And sometimes, because it's a hash, you might have multiple possibilities of plain text passwords, but they can detect, like, if they have like a 40-character thing with lots of special characters in it, and the same hash also refers to a 6-character password that has just letters, good chance that it's the one with the letters. So they have algorithms to also know which hash is the right, or which plain text is the right one for this hash. And basically, yeah, they just have the plain text again. So it's not really slowing them down. Now, the other thing you can do is a salted hash. The way a salted hash, in simple terms, the way it works is it just hashes the plain text with an additional key, which is random. You take the plain text, you store the random key, you store the resulting hash, and then when the person comes to sign in with the plain text, they take that, they type the random key, and they arrive at the same hash that you have in your database for comparison, right? And because you have this additional key, the number of permutation increases dramatically. But even that is not enough, because the processing power just keeps increasing, and people keep calculating those things. They're creating these massive tables with all the permutations. So as I said, they're always ahead of you, or they're always getting ahead of you. So what you can do is think about what your goal is. Your goal is to slow down the attacker, is to make it harder for them or longer for them to find a match, right, with a hash. So what you can do is go through multiple iterations of the hash. So you can force them to, instead of hashing once, you can force them to hash maybe 20,000 times. And that is going to slow them down. For the user who logs in, because you have to calculate the hash 20,000 times, for the user, it's not going to be a big deal. It's just a few milliseconds. But to the person generating a rainbow table, that is 20,000 more times processing power required. And the thing is, you have algorithms like bcrypt that allows you to do this repeated hashing. Don't roll your own crypto. Use something that exists, like bcrypt. And bcrypt allows you to specify how many iterations you want. So you can say 20,000 today, and in a year you can say, well, now that computers are faster, let's do it 30,000. You can just keep increasing it. So you basically make it constantly difficult for attackers to go and generate those rainbow tables. So you can pretty much stay ahead of them. So that's it for passwords. The last part is the response plan. So you need this emergency procedure, so when things go wrong, when you are breached, you can respond very quickly. And here's an example of a procedure that you can implement. Step 1, you log everyone out. So you are aware that something has been leaked. You can, with one click, you can log everyone out. And then you can mark all the accounts as compromised. So in the database, you can have a flag saying, is compromised 1. And when somebody tries to log in and they are compromised, because you do want to resume operations quickly, they log in, and it forces second factor authentication, because it could be the attacker who already found the plain text version of the password that is trying to access, say, your email account. And email account leads to other private information. They can social engineer their way into anything. So you force that second factor authentication because trust level has decreased because it's a compromised account. And once they have successfully gone through that, then you force a password change because the previous password is tainted. So you force the password change, and once they go through those procedures, you can once again mark this specific account as no longer compromised, and you can resume operations. And this is something you can go and implement right now. And just a final thing, what else can we do to make it harder for attackers to use the data once things are leaked? Start thinking about every data in terms of, do I actually need to store it? Or do I actually need it myself? Think about emails, for example. Why do you need a person's email? Because you need to email them. Okay, well, are you emailing them yourself, or are you using a third-party service like Mandrill or CakeMail to offload those transactional emails? Well, if you do, then you don't need the email. They need it. Maybe they need the vault for the email addresses. So once you start thinking about that in a bit more paranoid way, maybe, but in security, it's good to be a little paranoid. So start thinking about storing less data or offloading data storage to other services. Because when you centralize all of your data, it becomes vulnerable. People get way too much in a data breach, so you want to control what they see. So basically, together, let's protect that private data. Once again, my name is Filina. I will tweet the slides and follow my blog at afilina.com. Thank you.